Hi, AB students. This is your last assignment of the year. Even you juniors, this will be your last assignment. So you have this weekend to get ready. I intend to post some optional extra practice on Monday if you want to do a little brush up on Monday, a last tune-up, but it's optional. So I'm kind of expecting this might be your last or the last you hear of me. Also, probably record a good luck message, but you're ready. The calculus. Just show up and do your thing, and it'll be great. I guarantee it. All right, just stay out of your own way. All right, so let's practice a little bit. I try to choose questions that cover a lot of different units or a lot of different topics because I think that's what they're going to hit on the AP test. And not to mention, it's just good calculus to put it all together. So that's the goal, is to show that you know calculus from a lot of different angles to solve a big problem. And here we go. So would you try number 5? I want you to do number 5 all the way through, 15 minutes or less, to practice pacing. And then we'll go over the answers when you're done. So pause and do number 5. Clock at 15 minutes or less. All right. Big picture, big answers here are A, my answer was 6 grams with quality work. B, the answer is no. I said this cannot be the graph because the derivative is always negative or 0, never positive. Derivative less than or equal to 0. So it can't be increasing like that graph is, in essence. C, separating the variables, integrating, finding the C, solving for y. My equation was y equals, the rawest form of the equation was y is 1 over 0.0 t plus 1/10, which you could definitely clean up, but that's the rawest form. And then D, I got at the second derivative. And found the second derivative was something like 0.0008 y cubed. And for positive y's, this is always greater than 0. So the rate is increasing. All right. Now, I'm going to go back and go over the details on any of those. If you killed it and know that you did those right, cool. If you need to make corrections, gosh, doing these wrong doesn't do you any good. So go back and learn from your mistakes and make sure that your work matches. All right. So let's go to this first one. Anytime I estimate a tangent, use the line tangent to approximate the amount of substance. So I need a tangent line. I need a point. Sometimes that's called a local linearization. I need a point. They give me the point at time 0, 10 grams for t and y. The slope is dy dt at that point 0, 10. So that's negative 0.02. What do I put in for y? 0 or the 10? Well, that y is a 10. And so that is negative 200 times 100. That's negative 2. So my tangent line is y minus 10 equals negative 2. Don't use x, use t minus 0. Or y is 10 minus 2t. Now, using that tangent line to approximate how much there would be at time 2. At time 2, then, you'd have 10 minus 4 is 6. So I was not sure about the equal to all there, so I'm just going to say at the end to cover my butt approximately, because it is an approximation, 6 grams. All right. B. I alluded to this a second ago. But I'll say it again. I need to explain why this graph can't be right. Now, I could go one of two ways. I could say, actually, three ways. I could say either the values of y are not right, or the slopes of y are not right, or the concavity isn't right. Well, I don't really have the y equation, so I can't say why that graph wouldn't be right there, other than it's right in the first quadrant. I mean, it makes sense that there would be no negative amount of substance and time is positive, so that seems okay. But the first derivative, let's go there. If the first derivative is negative 0.02 y squared, then you needed to make the connection that because y squared is greater than or equal to 0, remember, squares can't be negative, then negative 0.02 y squared has to be less than or equal to 0. Because the derivative is less than or equal to 0, y must be always decreasing or flat. This graph is increasing at a point. So it cannot be the possible graph. So it's not correct. Okay? With good English, hopefully in your explanation. I was running out of room there. Please write like an educated person, okay? Write with subjects and verbs, and you've been taught well. Show that you have a good quality liberal arts education, and you'll separate yourself from even the kid that's really good at math but doesn't even write well. So, all right. Solve the differential equation with the initial condition. All right, so solving a differential equation means get rid of the derivative and get the original function. When you solve a differential equation, the first thing you should do is separate the variables. So I hope that you separated these. Now the question is, this is where I know some of you made your life way too hard. So that negative 0.02 and y squared, they don't have to go together. They're not attached at the hip, all right? They can be separated, and you should ask yourself, what makes your life easiest? Well, it's easiest to leave the y squared on the left and leave the stinking number on the right so it's easier to integrate. That's the easiest thing to integrate, not bringing, if you bring over the negative 0.02, your life gets harder, so don't do that. All right, so if you integrate this, I'm going to be careful and take the product or the power rule. Even if it's a fraction, it's not always natural log, it's a power rule, okay? So raise the power by 1, negative 2 plus 1 is y to the negative 1, divide by the new, equals negative 0.02t, and here's a constant, all right? So that's negative 1 over y equals negative 0.02t plus a constant. Let's use t equals 0, y equals 10. I get negative 1/10 equals 0 plus c. So c obviously is negative 1/10. So my equation now is negative 1 over y equals negative 0.02t minus 1/10. Now we have to get y by itself. It says solve for y. So let's get rid of the negative, and that makes everything positive. And reciprocal. Now, when you take a reciprocal, it's not reciprocal of each term. It's reciprocal of a whole side, all right? So, yeah, I was going to do an example, but let's just go with it. So, go away. 1 over all that is your answer. Plus 1/10. And clean it up if you like, but you don't need to. All right. Finally, come on, man. All right. Finally, is the amount of substance changing at an increasing or decreasing rate? Well, the rate is the derivative. The rate itself is the derivative. So to know if the rate is increasing, I need to know, is the derivative of the derivative positive or negative? So I need to take the derivative with respect to t of the derivative. All right. Now, this requires good chain rule. Check to see if you took this derivative correct. So when you take the derivative on this, it's the derivative with respect to t. That's very important. You note that, all right? So you got negative 0.04 y for the derivative of the outside, but then times the derivative of the inside, dy dt. All right, you should always say, all right, do I need to take just the normal derivative, but do I have another component? If I take the derivative of the variable with respect to t, do I get something? And you do. You get dy dt. That makes it negative 0.04y, and dy dt is negative 0.02 y squared. So that's positive. 2 times 4 is 8, and 1, 2, 3, 4 decimals. Y cubed. All right. Now, assuming y represents substance, then there's no negative substance. It's positive substance. So because y is greater than 0, the second derivative is also greater than 0. So the amount is increasing at an increasing rate, or changing at an increasing rate. All right. Cool. Let's move along to part B. I hope you killed that one. All right. Try the next question, a classic fundamental theorem kind of question. This is no calculator, so I can tell you that you're going to have to do some calculating. No big deal, though. All right, so do this question in 15 minutes or less. All right, let's see how you did. For g of 4, or g of 0, I got 3 halves. That was pretty easy. G at 4 was a bit of a mess. I had 11. Let's go down a little bit and check your answers to B. The absolute min I had was 0. And and then for C, the intervals on which I had -2 to -1/2, 1/2 to 1, and 5/2 to 4. If that's what you had and you feel like you killed this, then great. I got a lot of different students at different levels, and so if you're just killing this, don't waste my time with the explanation of something you already know. But if you're missing stuff and you have stuff to learn, then let's do it before it's too late. So let's get that college credit, baby. Let's go back up here and talk about A. All right, so A, G at 0. I started with the definition of what G is, which is an integral. defined function or an area accumulation function. So G at 0 is the accumulation of area under F from -4 to 0. Looking at the areas, this here I think was 3 and this was 5 given. So it's a positive triangle, which was 3 by 3 over 2, and a negative area of 3. So that's 9 halves minus 6 halves. And that's where I got 3 halves for that guy. B, let's go to B, or not B, it's all A still, sorry. G of 4, we're talking -4 all the way to 4. So I'm going to break this into 3 areas, or 4 areas actually. I'm going to go, let's just go 3. I already found one. -4 to 0 is 1, which I already found. 0 to 1, which is given. And then the stinker is 1 to 4. All right, so I know that this part is 3 halves, and then they're adding 5. And then we have to find the area under the curve from 1 to 4. Now, that one, they're testing your integration skill. You're saying, can you integrate -x squared plus 5x minus 4? That should be t's probably, but it's all good. All right, so we got 13 halves plus, and the antiderivative there is -x cubed over 3 plus 5 halves x squared minus 4x. Always show the antiderivative, then start evaluating. Don't combine those steps. So 13 halves plus, when 4 goes in, I get -64 thirds plus, what do I got there? 5 halves times 16, so 80 halves minus 16 minus -1/3 plus 5 halves minus 4. So that's 13 halves. Combining the thirds, I get -64 thirds plus 1/3 is -63 thirds. Whatever. 80 halves minus 5 halves is 75 halves. You could make that 40 and use it as a whole number or whatever, but I was taught to combine like terms. So -16 plus 4 is -12. Okay. So let's go here. 13 halves plus 75 halves is 88 halves. Right? So 88 halves is 44. Okay. Seems hinky here. What the heck is going on? -63 thirds is -21 minus 12. I'm getting 11. Yeah, sorry, that's right. So 11 is your value. That makes sense. You mostly accumulated positive area going all the way right, so that seems logical. All right. Let's go to B. Your work should have looked something like this. Absolute min must occur at endpoints or critical numbers. Please explain where critical numbers come from. Don't just say, here they are, you take my word for it. Say, critical numbers are where G prime, which equals F, is 0 or undefined. And that is at X equal, and what's that? -1, 0, and 1. Now, that's 3 candidates. And you can find G at all 5 with the endpoints. And it's fine. If you want to leave one out, then you better explain why. So, for example, as far as where one of those critical numbers could be an absolute min, don't they have to be a relative min? So you need to have F going negative to positive. So the only one that's really a candidate for absolute min is when the graph of F goes negative to positive, which is at 0. -1 is more of a max because F is going positive to negative, and F at 1 is neither a min nor max because F doesn't change sign. So you could find all 5, or you can say, I'm going to leave some out. G prime equals F only changes negative to positive at X equals 0. And so you could leave those out. I am in the habit of just finding all 5. And in the back of my mind, I know that they're not in, but it's just safe. That said, time-wise, if you're worried about time, then it's wise to think through it and dump candidates if you don't feel like they're viable. All right, so G of -4 is an integral from -4 to -4. That is 0 area accumulation. G at 0, I believe we already found in part A, and it was 3/2. And G at 4 is already found, so 11. So from that we conclude the least of the candidates. Then answer the question. Did they say what is the absolute min value of the function, or what is the X at which the absolute min occurs? They say what is the absolute min value of G? And the smallest of these values is 0. All right. Let's go to C. Find the intervals on the graph of G concave down. So I start talking to myself, and that's the beauty of being able to take the test at home. You'll be able to talk to yourself. Just talk it out. A little internal dialogue. G is concave down if G double, now connect to F. G double is F prime, which is the slope of F. All that needs to be negative to be concave down. So I need to look at the graph and say, where is the slope of F negative, or where is F decreasing? And this occurs on these intervals, if I did that right. Okay, now you might say, how do you know the midpoint of all those is halfway between? Well, it's parabolas, and so you do know there's symmetry across the parabolas. That's how I know. All right, there you go. There's 2 down, halfway done. All right, let's talk some tabular data here. This is also no calculator. It's, again, meant to get at a bunch of skills. So try this, 15 minutes or less. Go. Okay, so here we go. Here's your answers. A is, at least I have, e to the 4th over 2 minus a half. B, I have speed is increasing because V and A have the same sign. V at 3 and A at 3 have the same sign. Remember, speed is increasing is not the same as velocity increasing. So don't just look at acceleration. That would be if velocity is increasing. For C, I used MVT to prove yes. MVT to say yes. Obviously, there's a lot more to it than that. And then D was a humdinger. I said yes. There was a time. Doesn't ask you to find the time, by the way. But there was a time, and I used IVT on B minus C equaling 0. All right. Those last two are some of the harder ones where you have to do some thinking and writing. All right. So let's go to whatever part you have questions on. Get out the old red pen and think critically and learn from your mistakes. I'm bummed that this doesn't allow for us to have a discussion and ask questions. So I guess you have to ask yourself those questions. Think critically, all right? So here we go. How many miles traveled? That means distance. Now, distance, I open up my mental file and say, all right, that means this. So I started here. I thought, oh, absolute value, that's terrible. But if you look at V for that interval and say, well, that's TE to the 4 minus T squared, T is obviously positive and E is always positive, so that's greater than 0. So I didn't have to sweat the absolute value. Now, I don't know if you just didn't even think about it and lucked out or you thought about it, but you should have said, all right, actually distance is absolute value in the integral, but in this case, I don't have to sweat the absolute value because it's positive. All right, so now here we go. How do I integrate that? Well, I have a product, and one is a function within a function. So I hope you thought U sub. Did you say something like U is 4 minus T squared? Therefore, du is negative 2T dt. But I have T dt, so I'm going to divide the negative 2 over, and I'll be able to sub for the T dt with d over negative 2. On a definite integral, you should also change the bounds. So if t is 0, u is 4 minus 0, or 4. If t is 2, then u is 4 minus 4, or 0. Now that's going to be switched bounds. My integral then becomes 4 to 0 e to the u, and dt times t is du over negative 2. So what I'm going to do is take that negative, switch those bounds, and those two negatives overall will be positive then. When you switch the bounds, you get a negative. That'll knock out the negative. And so I'm going to have 1/2 e to the u du. That's 1/2 e to the u from 0 to 4. And that's where I got my answer, 1/2 e to the 4th minus e to the 0. All right. So that one required you to show you can use sub. All right. Remember, speed is increasing if velocity and acceleration have the same sign. So you need to define V at 3 for Chloe. V at 3 is the second branch of Chloe's piecewise. So that's just plugging in 12 minus 3t into 12 minus 3t minus t squared 3. And I got negative 6. The acceleration of Chloe is the derivative of Chloe at 3. And so the derivative is negative 3 minus 2t at 3. That's negative 9. And then my conclusion, because they have the same sign, they're working together. She's moving left and her velocity is decreasing, so it'll be more and more negative, bigger negatives. So she'll be going faster in the negative direction. All right. C. Now, acceleration is not given. So you had to say, well, acceleration of Brandon would be tied to the derivative of Brandon of velocity. And so why is there a place where the rate of change of Brandon's velocity has to be 2.5? Well, I don't have an equation for Brandon's velocity, so I can't take a derivative. But I do have his velocity at different times, so I could look at the change in his velocity over intervals and say, must there be a time where change is the same? Now, the first is if they say 0 to 4, then your first thing you should try is, what about the whole interval? Would you agree that Brandon's velocity increased by 10 in 4 seconds? So the true change in Brandon's velocity is positive 10 over 4 seconds. So that is 2.5. Now the question is, all right, just because the average change over the interval is 2.5, does that mean that there was a place where the instant slope or instant change was 2.5? And yes, that's the MVT. That's the mean value theorem. All right. So we're going to say, all right, now how do I show quality work? Well, first, anytime you use a theorem, you meet the conditions. And one of the huge ideas of calculus, and especially the AP test, is proving you know how to apply and use theorems. So first is show the conditions are met. I don't say f is continuous and differentiable. I'm talking the function I'm going to take the derivative on. So I'm going to say v is continuous and differentiable on 0 to 4. Actually, I could go closed. It's fine. So by MVT, there is a time in 0 to 4 when acceleration, and here's where I'm going to communicate acceleration. What does it have to do with the mean value theorem of the derivative? Well, that's the derivative of velocity for Brandon equals the average change over the interval, v at 4 minus v at 0 over 4 minus 0, which is 2.5. There's got to be a time in there where the instantaneous rate of change is 2.5. And D, is there a time where all right, so this one is rough. First, and you might have done the same, is I thought, well, I know at time 0, Brandon's velocity was 1, then 8, then 1.5. Okay. And Chloe's velocity is an equation, but at time 0, it's 0. And I guess I could do 1e to the third. And then at 2, 2e to the 0. 1e to the third is pretty big. And then 2e to the 0 is 0. So it feels like I must have crossed, but I still didn't know what. I don't know. So I just started talking to myself, right? So B equals C is the question. Is there a time where B equals C? Well, what really got me going is to say, let the net rate between the two, is there a place where B minus C equals 0? Well, what about at 0? At time 0, B minus C equals 1 minus 0, so 1, yeah? at time equal 2, B minus C equals. So B at 2 is 1.5, and C at 2 is 2e to the 0, which is 2 negative 0.5. All right. Now that is beautiful here. Look at that. B minus C went from positive 1 to negative 0.5. So surely, doesn't that mean there must have been a time where B minus C was 0 in between if it went positive to negative? So now so the question is, why do I know that? Why does it have to pass through 0 along the way? Well, that's the IVT. All right, so say something like this. B minus C is continuous, and 0 is between negative 0.5 and 1. So by IVT, B minus C must equal 0 at some point. So B must equal C. All right, that one was harder. That's kind of separate the very best from the good kind of thing. All right. Last question. Give yourself 15 minutes. This one is calculator active. The numbers are pretty big. I don't know how much calculus you need to do. It's just an arithmetic problem. So go ahead, and we'll talk about it in a minute. Okay, check and answers. Here we go. For the first one, I got the rate was decreasing at a rate of 216 vehicles per hour, decreasing. The rate is decreasing at a rate of 216 vehicles per hour. The rate is normally in vehicles per hour, and that rate is decreasing by 216 vehicles per hour every hour. B, the answer was 34,596 vehicles. C, I have 2,452. And D, 14.7592. All right. So hopefully you killed that and you're just shutting it down for the weekend, or you're doing this on Monday or Tuesday morning, God forbid. But anyway, if not, let's get out the red pen and learn from our mistakes. Okay, so you've got a table. Always be careful to not read too much into the table, and also be careful when it says approximate, that you know it's an approximation, and show it in your notation, all right? So if you're approximating an instantaneous rate of change, then remember the idea is you're saying a instantaneous rate of change can be approximated by an average rate of change. All right, so in this case, R prime at 5 is approximately equal to change in R over time over an interval. And with 5, it would be best to look at R of 6 minus R at 4 over 6 minus 4, which is 3,010 minus 3,442 over 2. That's where I got negative 216 from. Now the interpretation, show the computations. Using correct units, explain the meaning of R prime. So if R prime is change in R, which is in vehicles per hour, over change in time, and it's negative, then R, the rate of vehicles crossing a bridge, that rate is decreasing. And so our explanation should be something like at time equal 5 hours. The rate at which vehicles cross the bridge is decreasing by 216 vehicles per hour. The rate is decreasing. All right. B. Midpoint Riemann sum. Riemann sum means rectangles. So in each case, you're going to split 12 into 3 equal subintervals. So each delta t is 12 minus 0 divided into 3 subintervals. Now, you can either divide out the 4 because they're equal subintervals or keep them in, but you're going to go one interval from 0 to 4, one from 4 to 8, one from 8 to 12. So I'm going to say that this is approximately equal to delta t of 4 minus 0 and r at the midpoint between 0 and 4, which is 2. The next interval is from 4 to 8 and r at the midpoint between 4 and 8, which is 6. And then 8 minus 12 or 12 minus 8, r at the midpoint, r at 10. And that's where I got my answer. I did use my calculator for that. I wussed out. I didn't multiply by hand. All right. On a certain week and day, the rate at which vehicles cross is h. All right. So they're giving me an equation to work with now. H is measured in vehicles per hour. T is the number of hours since 7 a.m. Okay. Time 0 represents 7 a.m. According to this model, what is the average number of vehicles crossing the bridge per hour on the weekend day? So I read average and I think, all right, is this average value or average number, average rate of change? So average number of vehicles crossing bridges per hour. So that means I want the average value of the rate. They give me the rate, and so seems like I want to use that H equation and find what is the average of H over the interval. So I did that with calculator, and that's where I got 2,452, and it came out oddly equal to that, so not approximately. And then finally, like all questions, it's gradually building in complexity, and D took some careful reading and stick-to-itiveness on my part and your part. For 12 to 17, L of t, the local linear approximation to the function h, time is a better model for the rate. So they're saying this h of t function really only models well up to 12, and though it said in the question it continues on to 17, they don't want you to use the cube at 17. They just say keep going with a locally linear approximation. Now that's tangent line. So if you didn't understand the verbiage, local linear approximation means tangent line. So you're going to do a tangent line at 12 and really generate a piecewise, kind of make a line for 12 to 17. And then using that line, say, does there a place on that line where the rate is 2,000? Which I'll have to do that later. But first now we need a tangent line. So I need to do a tangent line. So that means I'll need a point. The tangent line starts at time equal 12, and the model will end at h of 12. H of 12, using the equation, at this point I felt like I'm going to need the point and the derivative, and so I felt like it was worth putting that into F1 in my calculator. So h at 12 is 2,596. The slope, when it left off, h prime at 12, was negative 216. So my tangent line, which, some of this, my tangent line then is y minus 2,596 equals negative 216 t minus 12, or y is 2,596 minus 216 t minus 12. And I guess that's, they said call that L, the line equation. All right. So now the question is, use L of t, and I've got that now, to find the time between 12 and 17, at which the rate is 2,000. So where's that 2,000 go? Well, that's a rate, and L represents a rate. So that means 2,000 goes in there, and I'm finding the time. So I need to solve this equation, and I really hope it comes out to be a time between 12 and 17, or else I made a mistake. So solving that, I get, I subtracted 2,596. 2,000 subtracted 2,596 divided by negative 216, and then I added 12 over, and that's where I got my answer of 14.759. That's vehicles per, that's time, that's hours since 7 a.m. All right, that's how I did it. All right, well, that is it. If you don't have time to look at my website or Google Classroom for any last-minute practice or messages, I understand. I cannot or do not require you to do anything past this. Just show up and be brilliant Tuesday. But I would encourage you to look at the AP reminders to make sure the logistics are set. And if you want some last-minute calculus practice, I'll post some on my website.
Hey, wake up, wake up. You remember me, you know, Mr. Rickman. Yeah, the tougher Mr. Rickman, you remember. Hey, I heard you guys are taking your AP test next week, and so I had to try to take over one last time. Last time I had you guys doing some artwork to give you guys a break from, Snoozy McSnoozersen's class. This time, I know that going into the AP test, it's important for you to have the right mindset. And I'm sure that some of you guys are anxious and nervous, but having my brother all year long as your teacher, I know that leaves you with a bunch of pent-up frustration, anger, confusion. So I wanted to give you guys a way to get all of that out in kind of a fun way. So here's what I did. I designed a game for you. That way you can play this game, get some of that frustration out, put yourself in the right mindset for the AP test next week. And so here's what I want you to do. If you have your phone with you, what you're going to do is you're going to pause me and you're going to scan this. Now, if you don't have your phone with you, that's no big deal. Just go back out to the calendar where you found the link for this video, and I asked my brother to put the link to the game right in that description as well. So if you don't have your phone, pause me, click on that link, go ahead and play that game. All right, hopefully you had a good time playing Angry Weasels and getting some of that frustration out from having my brother as a teacher all year long and knocking some of that stuff down. Anyway, I'm gonna try to talk to my brother and make sure that he's classy enough to maybe give the top 3 angriest weasels on the leaderboard some kind of extra credit or something, but I'll work on that for you. So I made something else for you too, because a takeover of my brother's classroom wouldn't be complete without some way of telling him that I took it over. So here's what I did. I created a Snapchat filter specific to you guys, Devlin, calculus class. So here's what I want you to do. For those of you who have your phone, and if you have Snapchat downloaded, go ahead and pause me, and I'm going to have you scan a code. And what I want you to do is I want you to play with it a little bit. I hid a few secret things in there. If you open your mouth, something happens. And if you get your hand into the shot, I put a little hidden piece in there as well for you. But what I want you to do is take a screenshot of it and email it to my brother and let him know what you really think of it. Okay? So if you have your phone, you have Snapchat, go ahead and pause and scan this code right here. All right, I can't wait to see some of those pictures that you send my brother. Anyway, I'll let you guys get back to your snooze fest. It's your very last snooze fest though. So that's pretty exciting. I'll leave you with this. You know, my brother may be a lot of things. He may be a doof, he may be a terrible dresser, a weakling, a terrible singer, smells a little funny, but there is one thing that I know he's very, very good at, and that is teaching calculus. So I have no doubt that you guys are so prepared for this test and that you guys will kill it. Good luck. You guys are ready. You will be amazing. He is really proud of you guys, so do him proud next Tuesday, okay? Good luck, you guys. You'll do great, and don't forget.
You can do it! You can do it! You can do it! You can do it! You can do it!